It's the control, essentially control your program branching, now repetition. Oops. Some of them I'll go through very quickly, the parts that you should know. And if there are some parts, just like this morning in the repetition, there are two people said, well, your code in repetition didn't work. They took it as is. They forgot some of the things that I mentioned, like basics, that you have to create a variable before you use it. I'll point that part out, but I'm not going to re-review every concept again. That wasn't the learning lesson. So loop and constructs. Constructs are tools, essentially, constructions. The ones you learned in Python, the for and while, and now for now the equivalent Java. There's similarities and there's differences, especially with the for loop. The Python for loop is just its own beast. The while loop between two of them, very, very close. General logic requirements, the syntax requirements is you have the keyword while. Some languages call it do while, but still it's acting like a while loop. Boolean expression, as long as it's true, we go in the body. And we don't actually swing back up here unless we have some abnormal control, or by default, we hit the closing end of that body. So Java, Python, the two look very similar. There's small differences that you should be getting yourself aware of is how do we signify the body? We have colon here, no colon here. This is signifying the end of the Boolean expression. However, over here, each statement has to be signified with semicolon. For loops. Now this is the one that's significantly different, and it's because of Guido and how he designed for loops for Python. It's significantly different from every other language that I have seen. Okay, regardless of the language, regardless of the type of loop, you have to have three basic things. Well, implicitly a fourth thing, a loop controller controls that determines whether or not the loop executes. It's controls. The loop control has to be initialized, it has to be updated, and then we have to check against condition. Syntax varies, but all sensible loops have to have these things. To say all sensible loops, you could have a logic error where you're skipping something. Some languages will let you, this part, some languages will let you get away with that. You don't actually set the control. So I isn't set to 1, for instance, you've created I, and who knows what's in there. That's where I get in the habit of, if you recall, because I've been stung in other languages, when I create a variable, I don't just do this. Java takes care of this. It's a language that protects you a little bit, and it sets some default value, I believe it's 0. But not all languages do it, and it could be just, it will be essentially whatever bit pattern was in that memory location prior to running your program. And because that bit pattern, who knows what will be previously, you can have very strange things happen in your program. Whoops, we're over here. Okay, so the initialization, sometimes it's not enforced by the syntax. The update is enforced by the syntax. But these are things you need for sensible loop control. So the two comparable ones here, Java, Python, the basic counting loop, initialized. This is another example here of where it's an implicit language. Yes, it's easy enough for you to handle now, but when you're first learning it, or at least some of you were first learning it, you look at this and you're going, well, what's happening here? This is more mathematical, but it's very explicit. Setting, that's the initialization. That's I should actually point these out because when we get to the more complicated one, this will be handy to point these out. Now, with the for loop in Java and some other languages, we can have multiple. These are the 3 parts required of a loop here. Each part, the initialization, is separated from the Boolean expression with a semicolon. And as we see, it's possible to have more than one instruction separated by that semicolon. That's the exception of the syntax. We could, for instance, and I'll show you an example like that. These two are part of the initialization. So the syntax specifies, if we put a semicolon here, the semicolon for the for loop's exception, it separates these parts, not expressions. So you do have to be aware of these parts. If you think, I'm pointing these out, why am I doing it for this example? Because it's so simple-minded. For the more complicated ones, you need to know that these 3 parts are separated by a semicolon, and it can consist of more than one statement. The Boolean expression here is separated from the initialization, semicolon. And then the Python Boolean expression, implicit. Not great as a learning language. Yes, you picked it up eventually, but it took a little more time than something like this. And again, recall example I went through a while ago that is this less than or is it greater than? Or does it include it? You have to memorize details like this. And this one, it depends on the sign, whether it's less than or greater than. Furthermore, the update of the control in Python, this is one of the differences we'll see. It's limited. It's either addition or subtraction. It doesn't have to be one, but you can't perform multiplication. Yes, I'm not quite finished this yet, but what's your question, Group? Did you type it in chat? I think I see something here. Oh, no. What's your question? So you have the floor here. Lower hand, don't see anything from you in chat. So lower hand, so you got the floor. Chat. A moment. Okay, here. Okay, you're jumping to something else. That's why I said I haven't finished it. Can you iterate through things? I haven't finished the counting example yet. So let's finish this. Someone else asked, what's the plus, plus, plus? That's where you're going to have to review because I actually talked about this earlier, basic operators. So I'm not going to take time to go through it, but just tell you that I've already gone through this. Okay, the update of the control here. Over here, any valid math expressions you see, unlike in Python, where you can only count up or down, in this case, this is the equivalent of this. But as we'll see, if you can type it in as a valid math expression, we can have ones that multiply, we can have ones that are power, or we can call a method. So if the loop basics over here, of course I have to declare, now you guys are forgetting some of the previous things already, like the plus plus. So knowledge is cumulative, so you need to review previous, go through that stuff and know it. Over here, there's another thing for this morning's class. They forgot that you actually have to declare a variable before you can use it. So if I took out this, well, it'd be a syntax error. And this would be a syntax error also in Python because I haven't set it to a starting value. So you really have to review this even if it's not explicitly in the quiz. Because these are basics that if you have to re-look things up or what's this when you're writing more complicated code, you're not going to be able to do the assignments. So loop basic, this is counting from 1 to less than the 4 here. And we increase by 1 here. And over here, the 4 equivalent, it's still pretty explicit. It excludes the 4, increases to equivalent approaches. Running these, let's see here, the output. So we display the I values, the while loop, for loop, logically equivalent. Okay. So that's the basic. Java versus the Python for loop. Counting loops. Now, more advanced things. Python. When I taught the for loop in Python, we all showed the advanced features. But I also, when I taught the for loop in Python, I said you cannot do most of these things with other languages. Most languages, for loops, are just described as counting loops, counting up and down, or counting through some mathematical sequence. That's all they do. Unlike, say, a for loop in Python, where you can step through lines in a file. You can't do that in other languages. And how they do this with Python is you're iterating through something or stepping through numerical sequences or lines in a file. The basic for loop in Java and other languages, you cannot do this. This I gave a foreshadow of in 231. There's a for each, which is different from the for loop in Java, and it's more limited than the for loop. So you can't do something like this. Now, at this point, this is probably fairly straightforward for you, but beginners, when I show code like this, they look at it and it's not explicit. This is where the implicit language, it's harder for beginners to pick up, which is a critique I have of using Python as a starting language, because it's implicit. It's actually harder than languages like C and Java. Although I try and mitigate by having good naming conventions telling you, okay, I have an input file, line at a time from the input file. But with Java and most other languages, the loop control update, unlike Python, repeat again, Python, you can only count up or down in addition or subtraction. Can't do anything else. And you can try and work around this. I tried to just see what happened. In the body, I think I made this 0, for instance, so it wouldn't update anything. And I tried increasing I, say, multiplication, multiplied by 5. We had very strange logic errors. It would change it, multiply by 5, and then over here, and override it by what's here. Then it'd go increase by 0. Multiply by 5, increase by 0. And you can't even predict it. It's going to do this. So you can try and get around to count up and down, but you really shouldn't. It doesn't work. In other languages, because you can put in any valid mathematical expression, you can type it out. Some weird formula, very complicated formula that is used in some research area, you can do that. Or you can call a method that implements some other mathematical function, random numbers if you want to. And of course, you can do that for while loop. Now, what I just want to also make you aware of, well, the for loop in Java is more limited than, no, the for loop in Python is more open than for loop in other languages. In Java, the for loop, you can do things that you cannot do with Python for loops. With Python for loops, you can't implement logical expressions. People ask, well, how do you implement and nor? Use a while loop. A for loop in Python is not meant to. Just to give you some idea, it's possible. We can implement just one simple one, we can do additional, more complicated ones. That's where knowing the parts, though it was a very simple-minded example, I think the initialization, it's separated from the Boolean expression with a semicolon. We can have multiple statements here, but unlike the normal case where statements separate semicolon, we separate a comma here. If you use a semicolon, then you're going to have problems because it thinks that this is the compiler is going to think that this is now a Boolean expression, and that's not a valid Boolean. So we have 2 loop controls here. But in my opinion, something like this particular example, it crowds a lot in a very small space. You're probably better off in terms of readability, even with a simple logical example like this, to implement it as a while loop. But if you have need for more simple but more complicated for loops, it's possible in Java. Now, this is the very example that I went through this morning and point out is another example. I assume that you have looked through and you have studied the material from previous lectures. So someone asked, they didn't show me their code. They said, what the heck did they say? And they were quite vague. They just came down after class and said, it didn't work or something to that effect. I said, well, was it a syntax error or logic error? They said, I don't know. And even take note of that, just said it didn't work. Well, logically, this does work because I checked the syntax. I had to root it out because I was trying to use semicolons here. I don't like the code this way. So for sure, I know if you do this properly, it does work. It actually counts through the X and Y sequences. But the question, I'm pretty sure I'm guessing what the person's problem was. They typed this and literally copy paste it in the code. What's missing here? If they literally did this, the variable declarations. So again, pointing out, you have to study and be familiar with the previous material, because I previously indicated, and I just indicated in today's lesson, that you have to declare your variables using Java syntax before you can use them. This part, I'll point out again, just contrast in how things are done. It's explicit, implicit here. This actually, some people might, even experienced programmers might remember things wrong, or you have the case where that's -1, and then this doesn't execute. Why? If I had -1 here, well, then that would be easy to tell what's happening. -1 goes from 1 to 0, 0 to -1. And this is going to be an endless loop. We could have an endless loop where this not execute, and it's very hard to figure out what's happening because it's implicit. Stopping boundary and other things where it's implicit here. People love it because I can bang this out quickly, but it's really easy to make mistakes. Again, I'm not bashing Python because there's some things that are better than Java, but the reverse holds true as well. Okay, this part I review because, and another thing, however, because it's easy to make this mistake. This is one, well, first, what's the error here? I'll ask you, so this is a review question. Stick up your hand if you can tell me what the error is. Or conversely, tell me what's happening, how that executes. And assume, again, there's the complete program so you don't have a syntax error. No one this morning class action. Oops, good. A hand maybe. Emmanuel, you got the floor here. I'll lower your hand so you got the floor.
Yeah. Can you hear me?
Go ahead.
Yeah. So for the first loop,
this one. This is
for the first one,
yeah.
It has two sections, but it's not in the same block. So, and there's no initial.
Sorry, what do you mean two sections not in the same block? What are you referring to? To clarify for everybody.
So in the system.out.println
Yes.
I, and also the I equals to I plus 1, they wouldn't be under the same while loop because they don't have braces surrounding them.
Okay, to clarify your comments here, the body essentially, it goes back to what I described. You're not incorrect, but I'm just clarifying for everybody, is how do you determine the body of a branch or loop in Java? It's either explicit curly braces, everything between opening and closing, or if you don't have curly braces, it is what follows the end of that Boolean expression, the closing brackets, and the semicolon. So it's a single statement. Whoops. Phil, no Phil. Yeah. So it's a single statement body. That's essentially what you're aiming to describe. I'm trying to. Yeah. Good. Thank you. And this is an optical illusion over here. It looks like it's part of the body, but it's not. So this is a mistake you can make. I think I've indirectly covered it because this is a very subtle error. Only one person volunteered. It's worth mentioning again. So this is likely, and assume that we've actually initialized this, some sensible value, likely going to be a logic error. Well, actually, it will be a logic error because we're not upping the loop control. So whatever value we start, if the loop body executes, I is 0, for instance, I could be 1, anything less than 10, it's going to print that value of I and never update it, endless loop. Ones like that can be tricky to actually debug. Any questions about this? This one's more subtle, so I'm reviewing a concept I talked about. Okay, another thing that people might do, I've done it myself when I was a student, and accidentally I've done it myself when I was a prof. This. So now some practice for you all. Even if you're too shy to raise your hand, try to think about this. Okay, I'll give you a moment here, Manuel. Don't say anything yet. So go through this and think about what will happen when you type this in. How does it interpret it? I appreciate that you're participating. I'll get you in a sec. Okay. Okay, so give everybody a chance. Now go ahead, Emmanuel.
Yeah. So the just like you mentioned in the slides, the error with that code is in the while section with the Boolean expression. There is a semicolon, and it's not supposed to be there because then it's going to cause it's going to throw an error.
Well, there's two ways it can interpret it. This is where we have the logic or syntax error. One is, and it depends on the language and perhaps the version of language. If we literally interpret what we described previously, the body is what's after. So I moved that over so you see a space after the closing of the Boolean expression and before the semicolon. It could take this as an empty body. And there were, an older version of Java would do precisely that, an empty loop body. And C, at least some of the C compilers I know of would do that. So what happens again? Well, this is even worse than the other one. We not only don't update the loop control, we have no output, assuming the loop actually executes. In the newer versions of Java, the compiler is able to interpret it to note this essentially empty body, and it becomes a syntax error, makes it easier for you to catch. These aren't uncommon mistakes, but being able to figure these things out, it goes back to the basics. How do you determine, how does the compiler determine what is the body of a loop or a branch in Java? Two possibilities. One is, this is the recommended approach. Use explicit curly braces. I like trying to make things explicit. Or you could do something like this. Now, if I have explicit curly braces, then I put a semicolon, then I have an empty body, either a syntax error or a logic error. I tend to avoid this approach because it's so easy to have mistakes like this somewhere along the line. Too many undo, so this is just a copy of it. Any questions about these mistakes here? Try typing these ones in, playing around with it, look at the results yourself. Now, if you didn't quite get this, you might ask, well, why would you want to do this? Well, the point is, you don't want to do these things, but you could inadvertently do these things and have really nasty logic errors in your program. And a good way of avoiding this is knowing those rules. How do you determine the body of a loop or branch? And using the curly braces now reduce the incidences, although it won't reduce an incidence of this. But at least if you remember the rules, you'll be able to interpret this. There was one prof who used to be notorious when he taught C in first year. He had exam questions like that. And essentially that was a logic error in C. And those ones were really hard to figure out. Very few people could figure out if you just missed that semicolon there. That prof's long works hard, and we don't teach C in first year anyhow. Now, this term you probably haven't seen. When I teach 231 myself, I do teach this concept and these terms, but I didn't last fall simply because there's so many other things that I don't normally teach, and I didn't have the time to cover it. Okay, well, this is what you have learned, although you might not have heard the term pre-test loops. This is something new. Now, this category includes a type of loops. These are specific looping tools. They fall under the category of pretest. Now, you see the characteristics of pretest, but you might not quite get why they are the way they are. We have some maybe generic pseudocode here, actually, because I have a more specific example later. Whoops. We always evaluate that Boolean expression with these types of loops before we execute the body. And if the first time through that Boolean expression evaluates the false, well, of course, we'll skip the body. Now looking at this part should make sense. In this case, it executes 0 times because whatever loop control we have, that Boolean expression is going to evaluate the false. And why does it execute 0 more times? Now, the pre versus post. It's essentially, do we test the Boolean expression first, or do we execute the body? The pre means we test the Boolean expression before the body. And it's top to bottom. So this is before this, so we test this. So this, with this pseudocode example, should explain to you why it executes 0 more times, and what I mean where we test the Boolean expression before the body. So you implicitly knew this, but explicitly, well, I'm teaching you a new term here, and I'm showing you explicitly these things execute 0 more times. Post-test loops, it doesn't exist in Python. Oh, Oh, sorry, typographical mistake. I copy pasted that. Python is only the do while. So one. There's no post test loop. Oh, dang. In Java, post test loop is a do while. To fix that in the online one. There's no post test loop in Python. To show you, no one mentioned that this morning. This is the approximate pseudocode syntax. That Boolean expression is moved here. So now you can see the Boolean expression is tested after the body. It physically resides afterwards. Even if the case we're saying that the loop control is set so the Boolean expression is false, well, this is before this. So we're going to go in the body at least once. It's guaranteed execution. And that's why the post-test loop exists. When would we want guaranteed execution? Well, suppose that we have our program, this. Yeah, you have enough of. So essentially we have a Boolean. And here we have, this is a main loop because it includes all or most of our program. If it's a game, for instance, we start the program, we want the ability to play the game at least once. After the end of it, win, lose, or draw, then we get the option to play again. We want guaranteed execution here. So there's one example of, well, when you want to use a post-test loop, guaranteed execution, like this. And it doesn't have to be just a game. It could be something for productivity, like calculating taxes. We start with our tax calculation program. That's coming up in just a few months. Your accountant does this. Oh, I didn't see that. No one raised their hand. Someone jumped ahead, started talking about the while and do while. Don't jump ahead, please. Now I'm getting to it. Someone actually is asking about it. Someone asked about iterating through lists. Okay, so over here, guaranteed execution. Oh. Pre versus post test loops. So now syntax here. This is actual Java syntax. So if we set the loop control to a value, such as this is going to be false, it's going to skip. And in this example, pre versus post, this is a screen grab of the actual output. The pretest never executes. So what we have before this is just output statements that tell you which one's executing. To versus post. Because when you're running this, you have the outputs of loops here and here, and this just labels what's about to come before the output of loop. But we have this message up here. This never executes because this evaluates the false. Then we go to the second one. It tells you that we're about to execute the post-test loop. With the post-test loop, even though I is still 11, we go in the body automatically because the check isn't done until after we execute the body at least once. So we'll see that message where it tells us post-test loop executes once, And then we display the I value, which has been set to 11. So we get the 11 from. Now we increase it to 12. Well, it's even more false, if anything. And we don't execute the loop anymore. So it illustrates the difference. 0 or more times, 1 or more times. That's the difference between the pre versus post test loops. And it's a conceptual thing. There's no loop in the language. You call it pretest, none that I know of. And it's implemented in the form of do while. And the pretest loops, they're not called pretest, but they're implemented in the form. Every language I seem to have the for and the while. They might call it something slightly different, but acts like a while. Any questions about the pre versus post now? Well, I have a question for you. Oh, wait, okay. Before I get to my question, Emmanuel, what's your question?
Okay, my question is, so in the Python programming language, you said there is no post test.
Right here, there's no post test loops in Python. Yeah, you might be getting on the
Okay.
about to ask. Yes.
Okay, so my question is, what about the while and else statement? Like in Python, if you say like while a certain Boolean expression do this, but if it doesn't equate to that,
There's no specific syntactical loop. What you're trying to do is simulate a post-test loop. That was actually the next thing I was about to get. What if you have a case where you want something to execute guaranteed at least once? This is where it's not necessarily a total loss in Python. Most common way of implementing the equivalent of there's no syntactical post-test loop, but you can implement it. I had mentioned it in 231 is, you see the post-test loop is built into the syntax, but you can simulate it even though it's not built in syntax. You can have, you mentioned one, here's another one that's more explicit here, less than 10. Then we have some body, oops. This is still a while loop. This is a Python one, because I'm saying Python has no post-test loop, but you could simulate guarantee execution, at least the gist of it, by essentially priming that loop control, setting it to a value. Oops, I should, since I'm on Python syntax, prime loop control. That's a common approach. You set it to a value such that it will guarantee to execute, but it's still not a post-test loop. Because if you don't prime the loop control properly, then it's not going to execute. The other approach, essentially, you're just trying to catch it with an else, or you can catch it, simulate it with an if, for instance, but that's still not a post-test loop. That's just trying to simulate that, get that one statement executed. That's not a great one, because if we have the body here, then we're going to have to duplicate the body over here. On the other hand, priming loop control, that's where you have the body once, just set to a value. So it's not necessarily a total loss that you don't have a post-test loop in Python. So here I don't hammer Guido because it's not necessarily a huge loss. But explicitly in the syntax, Java does have it. It's implemented in the do while. There's nothing explicit in the syntax of Python that has the equivalent. You can try and throw off the logic to try and mimic the behavior, at least guarantee execution once, but it's not built in the syntax. It's you programming it. Okay. So my question I was about to ask was, well, I had to answer it because your question, Emmanuel, led to it. Because there's no post-test loop, what do we do if we want guaranteed execution? We can simulate it with the logic. The break and continue. These are some things that are reviewed, especially at the break. Normally, with loops, true, we go in the body. False, it skips the body. That means there's only one place to exit the loop. It makes it easier to trace your program. You know that once we enter the body, we're going to step through, all things being equal, until we hit the end, we swing back up here. And even if the Boolean expression is false here, we don't have it jump out. Makes it harder to trace. And this is why generally the break is regarded as bad style. Now the break can continue. The modified behavior, if we see it continue, what happens? It just skips that iteration and loop and swings back up here. Not necessarily as bad. It doesn't exit the loop entirely, doesn't end it. It just skips anything here. The break, on the other hand, exits the loop right there. It's another exit point. There are cases where it's not bad style to have a break, but really there weren't ones that would come up in 231. The example that I cited was essentially when you're writing operating system software and you're not writing operating system software. Under certain conditions, you have an endless loop. And the only way to exit the endless loop, so it's equivalent to while true, literally true, TRUE. And there's certain times within an operating system, you want to have something execute all the time. Intuitively, you're thinking, well, your operating system is a program. And while your computer's running, it should always be running. So if we have a loop, for instance, controlling the whole operating system, at least conceptually, it's running forever. And until something drastic happens, like a blue screen event, your computer's about to crash, we don't want to continue because it's going to damage the files, writing corrupt information. Then we break out and get our blue screen. Those are the rare cases that a break is acceptable. Such a drastic situation. Because if we don't break here, and we, instead of having a blue screen, we start doing normal operating system tasks, we write to files, and those files become corrupt. And if we allowed that, then we'd have to reinstall the OS, which was worse than having the blue screen. The other reason why break is prohibited is myself. I actually put this very explicitly when I'm teaching by myself. I say, here's how much your features, here's how much you get for each feature. If you violate style requirements, I think this is minus a letter step. So you can go from, say, an A to an A minus if you have a break, one or more breaks. Another reason for why I prohibit the breaks in 231 myself, I agree with Professor Zal, it's a very good thing he did this, is then I've seen time and time again, students, they notice it after the fact, they implement a break, then they tell me, well, what do I do if I don't use a break? They're doing this because they don't know how to form a complex Boolean expression, or not even that complicated, it involves negation, and they don't know how to express it. As a programmer, you shouldn't avoid things just because they're hard. You're going to have to, the hard things develop your skills, and sometimes beyond developing your skills, it's necessary to be able to form those expressions. Usually the break is a crutch to avoid it, and that's a very bad thing, not just stylistically, but for learning. So an example with the break and continue, here, I'm avoiding IntelliJ just simply for the time. I'll just be able to go through the break here. Oh yeah, interpreting and not compiling it. So the first one is going to be the break part, and I separate the continue. So look at the break. The loop logic is supposed to go from 1 to 10, but right at the first value, and it explains why it's odd. I'll explain the odd. It doesn't actually go through the sequence from 1 to 10. I starts at 1, and it's supposed to count from 1 to 10. But this part with that break overrides that logic. So i's 1, what's this expression doing? It's essentially the module, the remainder operator. And it says if the remainder is not equal to 0, in other words, if this number I, the value in I, doesn't evenly divide by 2, and I doesn't evenly divide by 2 because it's odd, then this is true, and it breaks out. At the very first number, that sequence, it breaks out. Oh, I guess I have some time here. Now, in this case, with the continue, this one evaluates the true when I is even. Now, does 1 evenly divide in to 2? No. So it's not going to display 1, and it comes down here. It increases I from 1 to 2. 2 still is less than 10. Now 2 evenly divides and displays the values of I. And so the even values it displays skips the odd values. So that shows you continue. It continues counting from 1 to 10 if it's an odd number and less than or equal to 10. Even numbers is actually going to display it. That's the difference. So this isn't going to break out of the whole loop. It just goes to the next iteration. Break versus continue. Okay, so let's stop there. It didn't take as much time as I thought. And stop. Oh. Stop recording. Pause. Stop share. Stop recording. Types or categories of loops. We're not talking about specific implementations in a language. We're talking about all languages. Conceptually, what type of loops exist? What are the two categories? Anyone remember? One category is pretest. You were, oh, so now you're, okay, now you're starting to, just as I answered it, so people were answering. No, someone said for while. No, do the pre-post test. What's an example of a pretest loop? What are the examples of the pretest loop that we've covered in Java? Pretest? No, it's not a do while. It's for and while. These are the implementations. There can, for instance, be different implementations depending on the language. There's actually a do while or while do, which is which acts like a while, but essentially that's the implementation. I forget which language, Microsoft or Basic language, or maybe it's Microsoft Basic. The other category of loop is a post-test loop. And that's where you have, in Java at least, it's a do while. And the difference between the two are essentially things I described. It boils down to when you test the Boolean, the order of Boolean expression versus the order of the body, and that leads to the other things. Now, there are other examples of loops. I think I briefly mentioned with post-test loops that other examples within a category. Pascal, for instance, has a repeat until. Those are specific implementations, but you need to know the concept before you actually know the implementation. If you know the concept, then you can just look at the syntax differences, and generally syntax isn't a big deal. So these are some of the theory principles that you should know because they apply regardless of language. And the while, might be called something else, while do or do while in another language, but that's an implementation. Now, this another loop that we're talking about is a pretest as well. For each. This is a specific. The for loop is generally a more specific version of a while loop. A while loop you can use as an error handling loop. A for loop, generally, it shouldn't be meant as an error handling, say user input. A for each is even more specific than a for loop. It's basically used, it's approximately equal to such as lists and strings with the Python for loop. As I said, you cannot iterate through these composite types with a regular for loop in Python. You need to use a for each. I briefly mentioned a name, but I didn't talk about the details. Now, this is where I really got to get. Professor Hudson talks about the for each. On one sense, it makes sense that you're talking about at the same time you talk about the other loops. But on the other hand, it requires, again, another case where you have to jump around. It only works with certain types, such as an array or what is an array list. Maybe one other type. Those are two that I can think of. With this type here, now I have to actually introduce this type early. It's not on schedule until later, in case you keep wondering why I'm jumping around. He has a section that he called control. That's initially what I had, and I didn't look at details. Control normally refers to branching and looping. Under control, he also had this part, which really isn't control, defining functions, or the equivalent of functions, procedural programming. And under control, he had some theory. And then after that comes, what was it? Structures. That's where he actually schedules a talk about arrays, but I have to jump ahead just so you get some feel for what we're looking at. And arrays, they have their own little complexity. Now, fortunately, we don't have the problems that this morning's class or some issues. Recall that when you declare a type, when you create a variable in Python, let's make it a char. You have to specify the type for the name of memory location. Now, and then this is the name. Well, this is a type here. This is the name, and I'm calling it array because it is an array. An array is kind of like an array in Java is kind of like a very similar to Python list, but there's differences. And you access values through the square brackets. Now, to specify the type, this is a single character to indicate that this single char, to indicate that this is not a single character, but an array of characters. That's where in the type, you not only have to specify this, but this. And this is the other difference, but this is one of the differences between arrays and lists. Lists in Python are heterogeneous. You can have lists of different types. Arrays in other languages, they're all homogeneous. Every element has to be the same. You cannot mix and match. So every element is a character. That's what this is indicating. And this is indicating it's an array. That's the syntax. At this point, well, with arrays, I said with arrays briefly, and I said with reference objects that you have two things involved, not just one. Right now, it's not actually an array of characters, but it's a reference to an array. Add an extra little detail. I'm not being nitpicky because as I demonstrated in a previous lesson, if we just declare the reference to an object, we cannot call methods because that object by default is initialized to null. That's typically a constant in languages to indicate that we are not pointing at any address. We haven't created the array yet. The rough equivalent in Python if I try to index values, I'm going to get a null pointer exception because I haven't created anything, even at index 0. Same here. So this is by necessity, I'd say, I have to give you an idea what we're dealing with. I suppose it doesn't hurt to have this introduced a little bit early before I actually get into what he calls the structures. Any questions at this point? So there's some analogy with Python, so it shouldn't be too bad yet, but when we get the structure, there's more. Now this is where I create the actual array. What I'm doing is I create the array in one memory location here with 2 elements, and I put the address in that memory location called array. It looks transparent, just like with objects. If I refer to array and use an index, I'm actually dealing with the array. But there are times, just like with objects, if I pass array into a method, I'm not passing the whole array, but I'm passing the address of the array. So arrays, because we're dealing with references, are also passed by reference. You can change, as long as we have the address of this array in memory in a method, we can change that array. That's something to keep in mind. And now this part is very similar to Python. Once we've created that array, then we can, of that size, within the bounds of that array, we can then access or set elements. So that's what I've done. I've broken it down into steps. I want to give you an idea of what we're creating here before we talk about the for each. Any questions at this point? Okay, let me ask you this. If I just have this step, and assuming I have the full system.out. What will happen? I have a thought. Sure. Okay, well, at this point, I haven't created an array, yet I'm trying to access index 0. What's stored in that memory location called array? The hint's right here. It's null. It points to no address. So I'm going to get no pointer exception or the equivalent. Now, terminology. I said we're dealing with references. When we have objects in Java, we have to deal with references, and we have to deal with references with arrays. I also said earlier, those who are taking good notes can be handy so you're following along, that references are very close to pointers. Both of them store an address. The difference you'll learn in the second year course 355 is that with pointers, you can do things that you can't do with references, which isn't necessarily a bad thing, because if you're a beginner and you start doing the pointer things, well, you can really get yourself into trouble. Now, I mentioned that because you think null pointer, essentially a reference is a pointer, but you can't do as much. So yeah, null pointer exception because we haven't created an array yet. You actually have to create a memory location. What if I do this? What will happen? And you should be taking down notes at this point, because if you do, well, you at some point you'll need to deal with arrays, whether this course or another one, or even professionally in Java. You need to understand what's happening here. Well, I still have no array yet, and I cannot access any elements, non-existent arrays elements. So again, no pointer exception, it crashes. What I need to do is I create that array down here. So this actually gives you a tip as to what's happening here. Now I've created this array. So array points to array. We've created an array of 2 elements. Now I put the address here. Now with this new, this is a hint here. This is where we're actually an array or an object, a new array, new object. Look for that keyword new, and that gives you a clue when we've actually created the item that the reference is referring to. An early preview here, because it's kind of complicated, so it's probably a good idea to preview it, even though it's not mandatory in this section, is we're creating this array. It will show up in, where the heck is it? In the Intro to Object-Oriented Programming. Because he talks about it in that, in the control section. I need to talk about somewhere in case it shows up in quizzes. We're creating it dynamically. The dynamic sounds fantastic, but the thing is, we don't create it until we have to. It hasn't been created here, so the dynamic means we create it on the fly as needed. And it's creating a location, so you see this term early, in heap memory. In RAM, as you'll see when we talk about the next section, memory is divided when you run a program into different sections. You've got your instructions in one part. Heap is for dynamic memory. Dynamic memory gets used when we have that in Java, that new keyword. When we create an object with new, when we create an array with new, then we're going to actually allocate or create something in the heap. And once we have created that array, then we can act, and this indicates the number of elements. I should talk about it one. In case it wasn't explicitly abundantly clear. It goes from 0 to 1, just like a list. That's the common convention. 2 elements, then the indexing starts at 0, so we go from size -1 or 2 -1, last index, and we put values there. When we actually deal with a so-called array of objects, which I don't know if it comes up in terms of coding for your assignments, because I haven't seen all the details, but it does come up when you code up things in Java. So it's a good idea to talk about that so-called array of objects. There's some complexity here. That's why I'm calling it so-called. That's what you'll see it referred to. Then there's an additional level of complexity. you have to deal with another level of references, but I'll get to that later. Maybe you want to put yourself a note here saying if we're dealing with an array of non-primitive types, not int, not char, Boolean, but something that's a reference, now we have to do an extra step. If you forget this step, no pointer. We haven't even created an array. If we have an array of objects and you forget the second step, we have no pointer again. I'll get in the second step later. So before I get to the explanation of that for each loop, is there any questions about the creation of this array, the basics of this array? Okay, now that I have created the array, I can use this for each. It's not called explicitly for each, but this is the syntax. This is what's referred to, is we're stepping through element in this array. That's what the syntax is referring to. And each element is a character. And then once we retrieve that element, this is the element in the array, an element, then we can pass that to println and display it on the screen. The learning objective, the main one, was showing the for each, which is approximately equal to, oh, I've deleted it. The for loop, where we're going through lists and strings, but it's not the general for loop. That's something you have to use a specific one, and it's more limited. Any question here? Don't mix and match types. What happens if I have a single character? Someone says, well, what if we try and put an integer in there? What happens if I have a single character like this? I try and put an integer. I've shown some examples. Let me ask you this. Who asked the question? Kaden, you asked that question about an array. What if I do this? What should you expect? And why is it an error? What's the problem? You said it's an error. That's really what you should expect. Java is strongly typed. You can't mix and match types unless it really makes sense. Now, you do know that characters have ASCII values, but in most languages, what you're going to have to do is convert this to an ASCII code. Say, we will convert the equivalent of, word. I can't remember what the name of the one off the top of my head is, but I'll call it just convert to ASCII. So it takes that value and returns a character. And you really shouldn't do stupid things like that. Try and break the system. It's strongly typed, so you shouldn't do that anyhow.